This is part 4 of creating the printer object, and if we look at the UML diagram, we're done with the UI references, the interface, the extruder position, and most of the methods on the printer object. So we're still left with set temperature, extrude amount, and the feed commands, and then we have pretty much everything else done. So let's go ahead and get started on the feed commands. And I'm going to start by making a copy of my printer demo 3, and I'm going to call this printer demo 4, and we'll open the project file and save as, rename printer demo 4. Okay, so the feed command is just like the rapid command, except it's also going to be extruding filament. And in order to figure out how much filament it takes, it's also going to need to know the width and the height that it's trying to, of the volume it's trying to fill. So let me start by copying the rapid command, and I'm going to add it to printer class, which I should have done last time, but go ahead and make a copy of that, and I'm going to call that feed, and I'm going to save. And let me take a quick look at this just to make sure nothing's broken. Okay, hold on a sec. Let me go ahead and change the icon for this. So this is going to be a feed command now instead of a rapid command. Save. Okay, so these are still rapids. That's good. That means I haven't broken anything. So as I said, we're going to take an XYZ position that we're going to feed to, and then we're going to calculate the distance from where we currently are to this position, and that's going to give us the length of the plastic that we're laying down. And we're also going to pass in a width and a height, and that's going to give us the other dimensions that we need to calculate our extrusion. So width, height, and we'll assign those to pins. And now let's look at the block diagram. So this is the block diagram for rapid. And we have two new inputs. Move these out of the way a little bit. And the big difference between the feed and the rapid is the G-code command that we set. So instead of retracting the filament and then doing a move, XYZ, and then re-engaging the filament, instead we're going to do a coordinated move, G1, to an XYZ E location. So we're going to move XYZ and the filament, and we have to do this at a slower speed because it takes time to melt and extrude the plastic, and then we won't need to re-engage the filament when we're done. So this changes the number of inputs as well. So we have 1, 2, 3, 4 inputs. And for some reason we don't have the right number of inputs here. So let's just go ahead and delete some of these wires to start. One, two, three, four. Now we had 4. Okay. So the input 1, this is going to be our x. And input 2 is y. Input 3 is z. And now we need our e value. And we could just go ahead and put a bunch of math in here, but that's going to be kind of a mess and kind of complicated. So what I'm going to do instead is I'm going to create a little helper VI that just calculates the amount of filament to extrude given x, y, z, width, and height. So let me give myself a little room here. And I'm going to create a new VI called extrude amount. So that's this extrude amount here. And this one is not going to generate any errors because it's just going to do math. So I'm going to get rid of these lines. It will take a printer in because it needs to know the location of the print head before the move. And it's going to take an X, Y, Z, and a width, and a height, and it's going to output, actually it should be a numeric indicator, an extrusion amount. So let's hook these pins in. And we'll change the icon. Extrude amount. So let's look at the block diagram. And we don't have an error, so we can remove the case structure. And we'll get rid of this line, extrusion amount. So X, Y, Z, width and height. And so now we're ready to do our math. Now, the first thing we're going to do is we need to pull out the current printer head location. So we're going to unbundle here. And we're going to grab our X, Y, and Z. And let's go ahead and also calculate the final value of our extrusion. So that's going to require that we have our E value. Now, for calculating the distance that the printhead is going to be traveling, there's a formula for doing that, and it's the distance traveled is going to be the distance in the x direction squared plus the distance in the y direction squared plus the distance in the z direction squared, and then the square root of all of that. So square root of delta x, delta y, delta z squared. And so let's go ahead and calculate that. So first we need to calculate the distance between where we are now in x versus where we want to go. So that's just subtraction. So extruder x minus new x. And then we want the same for y. So extruder y minus new y. And we want the same for z. Oops, that's the wrong one. And extruder z minus new z. And then let's see if we can clean these up a little bit. It's a little better. So now we want to square these. So that's here. And then we want to add them all together. And I'm just going to use two additions here. There's a way of adding all three at the same time, but it's not worth the effort. And now we need to take the square root, which is right there. So this is the square root of x squared plus y squared plus z squared. And then we want to multiply that by the width and the height to get the volume. So here's the width. And here's the height. And then we need one other thing, which is the amount to move the filament for each cubic millimeter of plastic that we want to extrude. And take a look at the extrusion video for more information on that. For now, on the printer, there's actually another value. So I'm going to add an element, and actually I wanted this. So you'll notice there's this flow rate constant, and this relates the amount that you actually move on the e-axis to the amount of plastic that actually gets extruded. So for 0.23, that's the value you want that. So if you move 0.23 times this number, that actually extrudes 1 cubic millimeter of plastic. And so we're going to multiply that in as well. And that gives us our final answer on how much additional we need to move on the E-axis in order to extrude the right amount of plastic. Now, since we're using absolute coordinates, um, let's say this turns out to be 3, for example. So we want to move 3 on the E-axis. If we actually do a G1 E3, that's going to move the axis to absolute position 3. And if we're already at 3 and we move 3, it won't actually extrude any plastic at all. So what we want to do is add this to our current E position so that it goes 3 plus wherever we are now. And that will actually cause some plastic to feed. So if we're at 3 and we add 3, then it's actually going to move to 6. So let's go ahead and add the current extruder position to the amount of plastic that we want to extrude. And that's our final answer. And let's go ahead and link the printer in too. Actually, this is going to be a little tricky. Right. Okay. So I'm going to actually just move this over here because LabVIEW is hard to use when you're working on a small screen here. There we go. All right, so now we're feeding our printer and calculating the correct extrusion amounts. I'll move that back here now. And we'll save this. And this is actually just a bug in LabVIEW. So if we scroll that off and scroll it back on, it will go away. See, so now it's gone. All right. So now we know the extrusion amount. Let's go ahead and copy this here. And we have our width and height. So here's our width. Actually, make sure that's correct. So our width and our height. And we need our printer. And our X, Y, and Z. X, Y, Z. And that gives us our extrusion amount, which we can layer in. And now, after we've done that, the other thing that we need to do is, since we've changed the extruder position on this axis, we need to make sure that it gets bundled back in to the object when we're done. So here's where we're bundling in the G-code sync. Let's go ahead and add the extrusion amount. And I have that on this pin right here. There. So that's going to remember the correct value for the E-axis. And that should be it. That should be everything for extrusion. So let me save it. And let's go ahead and write a little test program. So I'm going to start with my test serial sync, actually test file sync to printer. Let me open this and do a save as, copy, add it to printer demo. And I'm going to call this test extrusion to file. And let's change where it's going. So we're in printer demo 4, test extrusion dot G-code. So let's just draw a simple square in plastic. So all of this up to here is going to be the same. And we're going to change this rapid. And what we're going to do, get rid of these wires too. So first we're going to rapid to the start of our square. And the size of the printable area on the PrinterBot Junior, it goes from something like 0 to 150 millimeters on X, and from 0 to 120 millimeters on Y. And so the center of the bed is going to be around 75 and 60. So X of 75, Y of 60 will get us to the center. And so let's rapid to the middle of the bed. Okay, well, so after we come out of here, our height is 5 millimeters. So we're going to rapid to the center of the bed. So our X position is going to be 75. And our Y position is going to be 60. And then we're going to rapid down to a reasonable print height. So we're going to rapid Z down to, and I'm just going to use 0.2 millimeters here. So that's thick enough that it should print. For a high resolution print, like we'll be doing later in the lab, I'm going to be using about 0.125. But for now, I want it to be a little thicker. And so now we're in the position that we want to start printing our square. So let's print up. Actually, where's my feed? Here's my feed. So now we're going to move to the X75. So same X position as we're already at. But now, in the Y dimension, we're going to move up 10 millimeters. So we're going to move from X75, Y60 to X75, Y50. And we're going to keep the same Z level, which is 0.2. And let me move all of these up. Okay. So there's the first leg. And then the second leg is going to move in the X direction. And then we're going to move back down in the Y direction. And then we're going to close our square. So we move from 7560 to 7550 to 6550 to 6560 and back to 7560. So that will move us from 7560, 7550, 6550, 6560, and back to 7560. After we've done that, we'll be ready to close, and this will raise the printhead to a safe height and then exit. Okay, so one other thing that we need to do is we didn't specify the width and the height. So the width is going to be how fat we want to print the line of plastic, and the height is going to be how thick the thing is from the bed. So let me go ahead and set the width to the size of the nozzle, the extrude, the part where the plastic actually comes out, which is 0.4 millimeters. And I got that on the wrong one, so let me fix that. And now the step over, or the height rather, that's this Z height here. So we're going to fill 0.2 millimeters there. And so let me copy and paste and paste, paste, height, width, height, width, and height, and width. So now I should have a program that will actually print a square. And let me save this and run it. Go back to the front panel and run it from there. So we just created our test extrusion.g code, and let's take a quick peek at the G code first. So in printer demo 4, now we have test extrusion.g code, and we'll look at it in Notepad. So here's our startup sequence, and we're waiting for the printhead to warm up. Then we retract the filament, we go up to Z5, and then we retract the filament and hone to our point above where the square starts. We go down to our print height, Z.2, and now we actually, this is not quite right, So this should be going E minus 3 E. Oh, no, this is right because we haven't extruded any plastic. Never mind. Okay, so the extrusion is zeroed out. We do our first leg. We go from 7560 to 7550, and then 7550 to 6550, 6560, 7560. So that closes off the square. Then we raise the actually we back off the print height, right? This is the amount we've extruded minus 3, and then we home I'm sorry, we lift the print head up to a safe height, and then we move back to 0, 0. So we clear the print and shut down the machine. So this all looks correct. Now, one thing that's really nice that we can do is there's a program called Repetier Host, which I have here. And I can actually load a G-code file into this. and get my EET folder, and see in Repetier what the actual object is going to look like. So I'm going to go to my test extrusion.gcode file, and here's the G-code I just loaded, which is what I was looking at Notepad. But now I have this little window that I can sort of drag and drop, and I can zoom out, zoom in or zoom out. I can change the view. So I can show the print head travel and zoom in a little bit. So we see, rotate this. So this is what the program will actually do when it's run. It will home the machine, raise it to X5, I'm sorry, Z5, then it will move the print head over to here, drop the print head, drop the print head to point 2, and then it will draw this square. Then it will raise the print head back up and move it to the 0, 0 position. So it's actually doing what we want. And we can visualize the G code here before we actually run it on the printer. So it can save a lot of time on more complicated models. So for example, let me show you what I had loaded before. So this is one of the rings that we're actually going to be printing in this lab, not too far from now. And this is a big one, so it's going to actually take some time to print. The estimated time is 33 minutes to print this object. But we can view it in Repetier very quickly. So we turn off the travel. So we're going to be printing a little ring that looks like this, and it has PCC on the front. And then it's got this sort of Celtic weave going around it. So instead of waiting a half hour to actually see what it is we're printing, we can actually look at it in the simulator, which is actually pretty cool and free. So now that we know that our program is doing about what we want it to do, let's go ahead and actually run it on the printer. So I'm going to save this as, and I'm going to call this test extrusion to printer. And I'm not going to save it to a file, so I can get rid of this. I do need a Visa port as usual. So here's our printer COM port, which is going to be COM3. And now we're going to change this file sync to a serial sync. And we're going to change the file init to a serial init. And we're going to wire in our COM port. And that should be it. That should be all we need to do to actually run this on the printer. So let's go ahead and run it with the test extrusion to printer program. And I'm going to go ahead and press the play button. And the printer is already a little warm from before, but it's going to take a little tiny bit to heat up. So it's turned on the fan, and you'll notice from that little gear at the top that when that's turning, it's extruding some plastic as it moves. So it's actually working correctly. And the actual print itself is very thin. It's only 0.2 of a millimeter, so it's kind of hard to pull off without breaking. But that's still thicker than we're actually going to be printing when we print our ring object. So at least we know that it works correctly. So let's continue. So now we have an extrude. Let's go ahead and do extrude XY and extrude Z, or feed rather, feed XY and feed Z, which are just like what we did with rapid XY and rapid Z. So here's our feed Z. Pass in a Z. And also pass in width and height. So we're going to call our feed command. And we also need to access our X and Y. So X, Y, Z, air, width, and height. And we hook up our arrow line and our printer out, and that's it. And let's do the same thing for feed XY. So we have X and Y and width and height. Hook these up. I think I forgot to do that on feed Z, so let me go ahead and take a look. Go ahead and look at feed Z for a second. Yep, I forgot to hook those up. So let's go ahead and add those. Okay. Let's go to the block diagram. So width and height. Get rid of this. Grab a feed command. So there's the printer. And we need to get access to our current Z position. So here's our X, Y, Z, our airline, our width, and our height. And then we return our printer out and our error out. So now we can use those to change our test extrusion to printer. So instead of using feed XYZs here, we can just use feed XYs. So I'm going to replace this with a feed XY because we're already at the right Z height, so we don't need to do that. And then we just get rid of this. And we do the same thing here. One more. And finally this one. So let's save this. And I'm going to save as, and I'm just going to write over my test extrusion to file VI and replace it. Yep, it's already in memory, so let me make it not be in memory first. So I'm going to close that and close this. And now I'm going to try it. So it worked that time. Oh, unable to add it, but that's okay. It's already in there, so should work correctly. Yeah, so that's the correct version. So we'll get rid of our printer COM port. We'll add a path. That a little bigger. And we'll go to printer for test extrusion.g code. Make this a file sync. Initialize the file sync. rid of that wire in the output file name. Save it, and let's go ahead and run it. So here's the new version in Notepad, and we see it's basically producing the same results as it did before. This E is going up, and it's drawing out 7550, 6550, 6560, and 7560. So it seems to be working correctly. So let's look at our UML diagram again. So pretty much the only thing we have left is the set temperature, and then we're done. So the reason we're going to have a set temperature command is because go ahead and watch the temperature video. But basically, the plastic is stickier the hotter it is, and so when we print the first layer, we want to print that at a high temperature so that it sticks to the bed really well. But after we print that first layer, the hotter the plastic is, the more liquidy it is too. And if we're trying to print a 3D object with overhangs like this PCC ring, you actually want the plastic to be a little stiffer so it holds its shape and doesn't just sort of spill out. So what we're going to do is print the first layer at one temperature, but then after the first layer we're going to dial the temperature back so that the plastic is a little stiffer. And so we need a set temperature command on the printer to be able to do that. But it's going to be really easy. We're just going to go ahead and create a new static dispatch template. And we're going to call it set temperature. And it's going to take a target temperature. We'll hook that in and edit the icon. So set temp, and save it. And this is going to be the M104 command. Make sure that it's the right one. So here's M104, set extruder target temp. But this doesn't actually wait. Wait is M109, but that's sort of what we want. So we're going to print the first layer, and then we're going to set the target temp, and it's going to gradually decline while we continue to print. So that's okay. So we'll do M104 here. And what we want is the G-code sync here. Sorry, under G-code sync, we want the send command. So we're going to send an M104 command. And so we need to get our sync object. So there's our G-code sync. And the command we're going to send is going to be M104. Actually, this can't be a constant because we need to fill the temperature in, so never mind. But what we want is under the string palette. And it's the format into string again. And we're going to our format string is going to be M104 S%F, the temperature that we pass in, and then a new line at the end. And it gives us one pin to connect the temperature to. And an error line. And then it gives us the resulting string, which we pass to the command, and then the error out. And now we want to rebundle the G-code sync into the printer object. And that gives us a printer. Boom. So if we wanted to add a temperature display to the front panel, here's where we would update the indicator. And that should be it. Take one more quick look. So that's everything for the printer object. In the next videos, we'll start looking at actually printing some interesting geometry and working towards a ring and a globe.